Alright guys, how's it going? Hope you guys are having a great break. I know I am. So this video is chapter 5, vocabulary. And this is important because a week after we get in, we will have our test. Okay? So keep that in mind. Make sure, I hope you guys are studying. Alright, let's get into it. So the first word is earthquake. Earthquake, the shaking that results from the movement of rock beneath the Earth's surface. This one is obviously very simple. This earthquake, we experience earthquakes, so we know what it is, right? And that's why it's important to use the memory techniques, because the memory techniques allow the information to go from meaningless words to experience, right? You're able to imagine what the word means, and then that just allows you to remember and know what it means. So that's why we're doing all these memory techniques, right? So earthquake, just in case you don't know what an earthquake is, what we can do is just think about, okay, earthquake. So Quaker, earthquake, Quaker oats. Another example that was given in class was a duck, quack, right? So, and shaking. So you just tie those two together. So maybe Quaker oats, you're holding the Quaker oats as you're about to get your oatmeal, and then it starts shaking, right? Okay, moving on. So just tie those together into your memory. The next one is focus. Now, focus needs to be taught at the same time with epicenter, because they're both related, right? Focus is, let's see, we'll get the exact definition here. So the point beneath the Earth's surface where rock breaks under stress and causes an earthquake. Now, epicenter, on the other hand, is the point on the Earth's surface directly above the earthquake's focus. So the example that we gave is a monk is meditating and he's focusing, and as he focuses, he causes an earthquake. So you're watching him meditating, causes the earthquake. You're like, whoa, what's going on here? And then you're actually on an elevator, so you take the elevator up to the surface, and where are you at? When you were paying attention in class, you said Agani Shopping Center, right? Why center? Why Agani Shopping Center? Because epicenter, that's the key word. So the focus is beneath the Earth's surface where the earthquake takes place, and then directly above is the correct epicenter. Great. Moving right along. The next word is magnitude. Magnitude is the measurement of an earthquake's strength based on seismic waves and movement along faults. So with that, you look for key terms, right? Key terms. So, measurement is one of them. We obviously know it's about earthquakes. And then strength. So earthquake, measurement and strength. So it's measuring the strength. Now this needs to be talked about with seismograph, because seismograph also deals with measuring and strength, stuff like that. So with seismograph, it is a device that records ground movements caused by seismic waves as they move through the earth. So the distinction is that seismograph is the device. Seismograph. So let's create an image for seismograph. Now we'll skip magnitude for a little bit. So seismograph is the device. So seismo obviously is seismic, right? Seismic waves. So obviously that's dealing with earthquakes. Seismics. So graph. So what could you think about that will link graph to a device? So think about a device. Device. Think, what image could you create? So maybe you have, what we did in class was a giraffe, right? A giraffe. So we had seismo, So we had Elmo. Elmo is being, normally you would think Elmo would be on a giraffe, but we switched it around to make it even more ridiculous. A giraffe is riding Elmo. It's on Elmo. Elmo! Elmo song. Right? And what happens is an earthquake starts to happen. Earthquake is happening, and then they fall down. And as they fall down, Elmo takes out a ruler. Why a ruler? Because he's measuring, right? So he takes out a ruler, and then he's measuring. It's like, wow, that's a big earthquake, right? He's measuring the, and to link in device, you could imagine that the ruler has a device on it, right? It's like a crazy metallic contraption that's measuring the earthquake. Got it? Okay, now, I said that first because with magnitude, see, a seismograph measures, it's the device that measures, and it's represented in magnitude. That's why they say the earthquake had a magnitude of 9 or a magnitude of 7. So the seismograph is the device, and it spits it out, the information, in magnitude. So let's link up magnitude and strength. Magnitude, measurement, and strength. So, we can use magnet, and maybe the magnet, as you're playing with the magnet, maybe it's a magnet of a ruler, right? It's a magnet ruler. Why? Ruler represents what word? Measurement. Good. So it's a magnet ruler, and maybe it's a really big buff guy who's trying to open it up, right? Maybe it has 2 magnets, and he's measuring his strength. Easy. Moving on. Stress. Stress, in this context, is a force that acts on rock to change its shape or volume. Now, the example we gave in class was the Hulk. The Hulk gets stressed out, and he's holding a rock, right? And so he hits the rock. Remember, it's a circle rock, right? And then what happens? Exactly. It changes shape. So, and to make it weird, right? As he hits it, the rock turns into a square because it's changing shape. That's what stress is. Now, there are 3 kinds of stresses: compression, shearing, and tension. And we need to be able to distinguish between those 2, at least those 3. So, compression. Show me the physical movement for compression. I'm watching. I really am. So, compression, right? We did it in class. Compression is compress. You could also do compress, compress, compress. The next one, shearing. Remember shearing. Shearing is when, or let's move back to compression. So the reason why we're compressing is because the key word in compress is squeeze, right? Stress that squeezes rock until it folds or breaks. So it's a kind of stress that squeezes, squeeze. And then shearing. Shearing is stress that pushes a massive rock in opposite directions. Opposite. So where it has like a sliding motion, right? So they're sliding. So the physical movement for shearing is exactly shearing, shing, shearing. And then tension. Tension is the opposite of compression. And tension, show me tension. Tension. Right? Stress that stretches rock so that it becomes thinner in the middle. So tension, right? Stretching. Stretching. And just remember, stretching relieves what? Relieves tension. So you're stretching, you're relieving your tension. That's another way you can link up that. Okay, what I went through is all the information that's required for the bronze level. So if you're bronze level, that's all you have to know. right? And you get the grade, you get a 75%. Right? That's not very difficult, very easy. But chances are, if you're watching this video, you're probably a gold, right? You're at least a gold or a silver, because the bronze, see, the reason why the bronze are bronze is because they're not willing to do what it takes. You, on the other hand, are willing to do what it takes. And if you're a bronze watching this, you're probably going to shoot at a gold or a silver at least. So it's no mystery why you're at the level you are, right? If you're willing to do what it takes, you will become very, 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 very smart. You'll easily make good grades. Okay, for the silver level, faults. So faults is a break or crack in the Earth's lithosphere along which rocks move. So in previous chapters, we talked about the lithosphere in terms of a bridge. So that was the image that we used for the lithosphere. Why? Lithosphere. The lithosphere is lifted up by what? Exactly. LA, remember? Asthenosphere. So below is the asthenosphere. On top is the lithosphere. And so what we did here with faults is you imagine a cracker. Right? Why? Because a break or a crack. So a cracker. So you imagine a cracker on the lithosphere, on your bridge, and what do? You break the cracker. And then someone says, "That's all your fault." Got it? Okay. Now, there are three kinds of faults: reverse fault, normal fault, and strike-slip fault. And they associate with the three kinds of stresses. So the first one is reverse fault. And reverse fault, a type of fault where the hanging wall slides upward caused by compression in the crust. So the image that we use to remember this is, imagine a car reversing which direction? Upward. Exactly. A car is reversing upward, and a lot of you are like, why is a car reversing upward? And that is not the point. The point is, we're using the image to the picture in the story to help us distinguish the vocabulary words. So a lot of you got to get out of your head. Why are we doing that? What? The point is, we're using it to help us remember. Otherwise, you guys want to get F's. So yeah, remember, that's why we're doing it, right? Now, if a car is reversing upward, normally, if a car is on a wall, what direction would it go? Exactly, downward. So that's how we distinguish between normal fault and reverse fault. Normal fault is when the reverse wall is when the hanging wall slides downward. Now, reverse would be what? Upward. Right? Normally, it would go downward. Perfect. Now, reverse is compression. And it makes sense, right? If you're compressing something, one kind of comes up, right? Slides upward. And then the normally tension, as it squeezes, as the rock squeezes, becomes thinner in the middle, the hanging wall is going to go downward. Okay, strike-slip faults. Strike-slip fault is a type of fault where rocks on either side move past each other sideways with little up or down movement. That's shearing. Now just link up S, right? What letter does shearing start with? An S. So you look at strike-slip fault, starts with an S, boom, lock that into your memory. Okay. The next one is plateau. Plateau, a landform that has a more or less level surface and is elevated high above sea level. So, plateau rhymes with what? Flat. So, a plateau is a mountain, not a mountain, but it's a landform that has a level relatively level surface. Level, flat. Plateau, flat. Link that up into your memory. The next one, fold. Fold is a blend in the rock that forms where part of the Earth's crust is compressed. Fold. What happens? Fold. Blend. No, bend. Typo. A bend, right? Duh. Bend. Fold. Just think about, just physically fold, right? Fold. What are you doing? You're bending. You're bending down. Link that up into your memory. The next one, fault block mountain. This one's easy because in its definition, it has fault, block, and mountain. So, a mountain that forms where normal fault uplifts a block of rock. Easy, right? Easy, just remember normal. That's the only thing we really need to remember. Fault block mountain. A mountain where normal faults lift up a block of rock. Simple, very, very simple. Okay, the next one, seismic waves. I'm not going to go over that because we already did. That was in previous chapters. S waves. Show me S waves. Right? S waves, right? Which direction is it going? It's going up and down, right? Up and down or side to side. Now that's what S waves is. S wave is a type of seismic waves that moves the ground up or down or side to side. The next one is P waves. P waves is a type of seismic wave that compresses and expands. So what we can do is imagine a panda. Why a panda? A panda? Because it starts with a P, right? So a panda, you're coming over, panda's coming over, I'm a panda. And he hugs you, and what is he hugging? Is compressing, and he's hugging you too hard, and then your head starts to expand. Got it? Okay. I know I'm crazy. Surface waves. This one's very, very self-explanatory. Surface waves. What do you think that could mean? I don't know. Surface waves is when the waves, either one, S waves or P waves, reach the surface. Super simple. Okay. Alright, that is what is going to be on the quiz. Now, there are a couple words that I didn't go over, right? If you're a gold, I expect you to be a little bit more, take a little bit more initiative. So I'm not going to give you everything. I've given you guys a lot already. So I've told you how to memorize the words. So what I want you guys to do now, particularly the gold people, golden, is to come up with your own associations, because that's going to be more powerful than the associations that I give you. Because the associations that I give you work for me, not necessarily for you, because we have different memories, different experiences. So when you can find the associations for you, that is going to work a lot better. Okay, so the words are already there. You should see it. I'll put this in the description so you can see it. And yeah, hope you guys enjoy your break. I'm going to do chapter 6, so stay tuned for that. It should be up quite soon. Alright, good job guys. If you're watching this, you are awesome. Alright? And you're going to be very, very successful, and you're going to make your parents very, very proud. So, good job. Alright, see you guys.